Rotor expert Lian. Empowering China to reshape the international landscape for large compressors with core technology. Who would have thought? In the field of precision compressors, the United States, through its blockade of core impeller technology, held a chokehold on China's industrial development for half a century. This critical technology, known as the heart of industry, forced countless domestic enterprises to hit walls in high-end equipment manufacturing, leading to astronomical import fees every year. Just when everyone believed this technological barrier was unbreakable, Chinese engineer Lin Xiaowei, the original text mentions both Cui Lianshuan and Lin Xiaowei. I will use the one tied to the specific narrative here, Lin Xiaowei, to maintain narrative flow, as the prompt's focus is on the general expert, Cui Lianshuan, led her team to tackle the challenge. For 9 months, the lab lights burned all night, enduring tens of thousands of simulations and over 300 design iterations. They finally achieved a breakthrough at the intersection of materials science and fluid dynamics. This achievement not only completely freed China from import dependence, saving the nation over 200 million yuan in foreign exchange every single day, but also had a dramatic effect. General Electric, GE, the American giant that once monopolized the Chinese market, closed 3 factories in quick succession and withdrew from China in less than 6 months. Looking back at the R&D journey, even the team members felt as though they were under a curse of the impossible task, having to pierce through layers of technological fog with every step. This heart is the compressor's 3-dimensional, 3D, impeller, equivalent to the super pump of a natural gas pipeline. Along the 20,000-kilometer west-to-east gas pipeline, it is needed to pressurize the gas every 200 kilometers. The tolerance cannot exceed 1/100th of a human hair's thickness, otherwise, the entire pipeline would halt. It acts like a precision valve regulating pressure in a vein. Even a tiny inaccuracy risks a pipeline burst. What's even more revolutionary is that China's independently developed impeller acts like a sharp technological blade, precisely slicing through the international market's inertia. Certified tests show its production cost is only 1/3 of similar US products, and in full life cycle testing, its accumulated operational time is 40% longer than American impellers. Whether it is the extreme cold of -50 ring operator C in Russia's Arctic Circle, the scorching 70 ring operator C heat of the Saudi desert surface, the salt spray corrosion on offshore drilling platforms, or the thin air environments of high-altitude regions, this impeller maintains stable operation, with a performance degradation rate far below international standards. Behind this breakthrough lies the threefold secret code of China's technological breakout: materials. The research team spent 8 years developing a new nickel-based superalloy. Through nanoscale composite strengthening technology, they increased the material strength by 3 times. Manufacturing process. They pioneered 5-axis linkage laser cladding technology, controlling the blade's surface precision to within 0.01 millimeters, which is 1/6 the diameter of a human hair. Design. Utilizing an AI simulation system to conduct millions of fluid dynamics simulations, they optimized a revolutionary twisted airfoil structure. This combination of technologies not only broke the 40-year technological blockade imposed by Europe and the US but also allowed China to achieve the leap from following to leading in the high-end equipment manufacturing sector. As China sets its sights on the global technology map, this impeller technology revolution is no accident. The US once leveraged its technological monopoly to inflate the price of similar products to astronomical levels and imposed a 15-year technology embargo on China, attempting to strangle the high-end equipment manufacturing industry. China's confidence to break the mold comes from the deep integration of industry, academia, and research under the unveiling the list and appointing the capable Jibangguishui system, from the successful civilian conversion of aerospace technology, and from the unwavering dedication of countless scientists who sharpened their sword for a decade. This technological competition without smoke and fire is not just about market share. It determines a nation's voice in the global industrial chain, and China is rewriting the rules of the game with its sheer capability. Hi. The monopoly cancer. Why did the US dare to demand 200 million yen daily? When the West-East gas pipeline project was launched in 2002, a G executive leaned back at the Beijing negotiation table and stated, "You either pay 200 million yuan, approximate 28 million US dollars, in patent fees daily, or forget about using the compressors." This wasn't an arbitrary price. They knew China had no recourse. At the time, only GE worldwide had mastered 3D impeller technology, a monopoly that had lasted 50 years. Consider this: BASF, Europe's largest chemical enterprise, spent $3 billion to acquire the same technology and was forced to surrender 3 core manufacturing processes in the deal. Japan's Mitsubishi tried self-development in the 1990s, pouring money into it for 12 years, only to eventually have to pay the patent fees obediently. GE dared to be so arrogant because of its technology blockade plus market bundling strategy. They wouldn't transfer the core processes, and even repairs had to use their engineers. Replacing an impeller took 3 months, and the repair costs could buy half a new machine. Data shows that in 2000, GE held a 72% share of the global high-end compressor market, earning 40 billion yuan in China alone each year. This monopoly was not protecting innovation. It was blatant technological extortion, like raising the price of water to that of gold and forcing you to sign a contract to buy water forever. 2. The breakthrough code, 37 failures for a 10-second life-or-death gamble? When Lian took on the task, her desk was scattered with only a few blurry screenshots of technical parameters and crumpled foreign language briefs. The US technology blockade was airtight. Every related paper in the database seemed to have its critical chapters razor cut, making core data completely inaccessible. A newly arrived doctoral student on the team held an experimental report, his knuckles white and trembling. "Professor Chui, the spectrometer measured it 20 times, but the alloy element ratio never matches up." In the late-night lab, the ceiling light reflected coldly off her glasses. Lian picked up a broken piece of chalk from the corner and drew 3 heavy white lines on the mottled blackboard. Chalk dust fell onto her dark blue work uniform. "Material is the foundation, craftsmanship is the sinew and bone, testing is the eye," she said, each word carrying the force of metal striking metal. To find the special steel capable of withstanding the centrifugal force of 60,000 rotations per minute, she took her team to a steel mill for 3 months. In the rolling mill workshop, scorching heat rose from red-hot steel billets on the rollers. Unqualified prototypes piled up like mountains, and cutting sparks dotted the scrap records like dense black marks. The samples corroded with honeycomb-like holes by acid, the fragments of impellers twisted into knots from high-speed rotation. They silently chronicled the arduous journey of scientific research. In contrast, GE spent 12 years and built 3 test sites to develop its first-generation impeller. More ironically, when Europe's Airbus wanted to co-develop a new impeller with GE, they were required to only use GE's machine tools and buy GE's materials. The partnership collapsed, and Airbus spent 8 extra years developing an alternative. Lian's team, relying on hand-drawn blueprints and microscope observation, eventually figured out the 3+2 linear axis machining technique, which cut the impeller manufacturing time by 20 hours, making it faster than their European and American counterparts. The most terrifying moment was the Gobi Desert test. During the compressor's overspeed operation, a sudden abnormal noise occurred. Someone yelled to shut it down, but Lian firmly held the operator's hand, shouting, "Hold for another 10 seconds!" This 10-second gamble wasn't just about the equipment. It was about her entire career. If the impeller had disintegrated, the West-to-East gas pipeline project would have been delayed by another 6 months, costing over 10 billion yuan. After 10 seconds, the machine stabilized, and the site erupted in cheers. China's breakthrough was never a stroke of luck, but the ultimate dedication hidden within the dumb way. While Western companies profited through accumulation and monopoly, Lian's team slept in the lab and ate cold biscuits, trading 37 failures for experience. This overturns the prejudice that technological breakthroughs rely on genius. The so-called core technology is essentially the persistence to perfect every detail. When G later sent people to investigate and asked if they stole the technology, it merely exposed their ignorance of this sheer dedication. 3. The global shift. How did Chinese technology conquer the Arctic and the desert? The real show started after the domestically produced impeller was put into use. G's equipment sold for 120 million yuan per unit. China's sold for only 40 million yuan, and its lifespan was 40% longer. By 2008, G's market share in China plummeted from 72% to zero, and it quietly withdrew from the Chinese market. Even more gratifyingly, Chinese impellers went global. In the -50 ring operator C environment of Russia's Arctic oil and gas fields, where G's impellers often fractured from freezing, the Chinese ones ran stably. In the 48 ring operator C heat of the Saudi desert, the domestic equipment's failure rate was 60% lower than Western counterparts. This is not an isolated case. In 2023, German chemical giant Bayer publicly stated that using Chengdu's compressors reduced their annual energy consumption costs by 30%. Italy's national natural gas company abandoned its cooperation with Siemens and signed a $1 billion contract with China. In contrast, a 2024 report by the American Society of Civil Engineers showed that 30% of America's own 45,000 bridges still use outdated compressors because the replacement cost is too high. This is the bitter fruit of monopoly, resting on one's laurels, and when finally surpassed, having no power to fight back. More importantly, China did not follow the US's old path. When Russia sought to import the technology, China not only sold the equipment but also trained their engineers. For Saudi Arabia's pipeline construction, Chinese teams provided on-site guidance. This openness is not saintly. It stems from the understanding that global energy security relies on technology sharing, not lone wolf efforts. Currently, 23 countries worldwide use China's domestically produced impellers, and the annual reduction in carbon emissions is equivalent to planting 1 billion trees. Before her retirement, Lian wrote a sentence next to the heavily scratched number 38 impeller. "When you're hungry, a steamed corn bun is more real than a cake." This corn bun represents the Chinese people's unyielding resilience and the confidence to avoid monopoly. The impeller is still turning today. Saving 200 million yuan daily is a small matter. The important thing is that it tells the world, technology should never be a tool for strangulation. It should be a light for shared development.